We are asked to find an equation in the form y equals ab to the x power. So we know that's an exponential curve, and I believe that the x-axis is an asymptote for that curve. And it has to go through 2 points. When x is 1, it should return 250. And when x is 4, it should give me back 4,000. So it says use the system below to help find the parameters a and b so that you may write the equation. So you can see what I've done is I've plugged the x value, and the y value, the x value and the y value twice to create 2 equations, right? So one of them becomes 250, that's the y, is equal to the ab to the x, and the x is 1. So this top equation, right, I'll put a little blue dot by it. This one is being generated by this point. And the other equation, I'll put a green dot by it. This equation is being generated by this point. So now I'm presented with a nice system of equations, and I'm just asked to figure out the values of a and b. Those are my parameters. Once I know the a parameter, which is my 0th term, and my b parameter, which is my multiplier, I can write the equation in this target form, right? This form that we're trying to hit. So let's do that. To do that, we're going to begin by, let's see, I'm going to choose, hi, just a moment, let me pause this. So if I take this first equation and I solve it for a, right, to do that, I'm going to divide, I could solve this for b also, couldn't I? Because that is b to the first. I can go either way on this one. More generally, I go with solving for a. But so let me stick with that. I'm going to divide both sides of that equation by b. When I do, I get 250 divided by b is the same thing as a, right? I just divided both sides by b. What's nice is I now have this expression 250 over b, which is a valid substitution for a. So I can replace a in that second equation with 250 over b. So if I do that, the second equation becomes 4,000 equals a. Hello, 250 divided by b times b to the 4th power. B to the 4th power, right, is b to the 4th power over 1, and it might help you seeing it that way because now I can see that I have 4 factors of b in the numerator and I have 1 factor of b in the denominator. And to simplify that, that's just going to become 250 b to the 3rd power, and over here I've got 4,000. Well, if I divide both sides by 250, I get 4,000 divided by 250 equals b to the 3rd. I have no idea if that's a nice number or not. Let me try it real quick. 4,000. Oh, that will be a nice number, won't it? It has to be a nice, because it goes in 4 times. It should be 16. Yeah, it's 16. So I get that 16 is b to the 3rd power. So I could take the cube root of both sides, right? But to be honest, it's easier for me to think about raising both sides to the 1/3 power. If I raise both sides of this to the same fractional 1/3 power to the 1/3 power, I don't change the equality, right? This is going to be preserved. But what does happen, what's nice about this to the 1/3 power, is when I have this power, a power raised to a power, I multiply these. So I get 3 times 1/3, which is just plain old b. So this is going to become b on this side. And on the other side, I get to ask my calculator. Let's try 16 raised. Let me type it. I'm wrong calculator. 16 raised to the 1 divided by 3 power. 16 to the 1/3 power. It is not a pretty number, right? It's this. 2.5198421. And I don't know why I wrote all those down, but that's a little sad. And I don't think that's I don't think I could convince that to go to a fraction. No, I can't. Okay, so I have my value of b, and I am not going to delete the decimals from my calculator screen. I'm going to want all of those as I go back in and try to calculate what a is. And I can see from the very top, a is going to be the same thing as 250, right? Take 250 divided by b that I just found, and that will give me a. So let's do that. Let's take 250, 250 divided by, I can just go grab it. That's b, enter. That's not pretty either. So I get therefore a is 99 point, let's go to 2 decimal places, 21. And for this one, I'm going to call this 2.52. So if I write my answer, right, it's going to look like this. Y is equal to A, 99.21 times B, 2.52 raised to the x power. Oops, off the screen. There we go. So that should be my answer. But I am going to try this. I want to plug in 1 and see that I get 250 or very close to it, and plug in 4 and see if I get close to 4,000. Now I am using decimal approximations here. It would probably be better if I use these. Actually, I think I can do that. So let me do this. I'm going to take, this is A. I'll just go grab A, and then I'm going to go times, let me go grab the B, and then I'll raise it to the power of 1. And when I do that, it gives me 250. Let me go grab that equation again. So now I've got the whole equation, and instead of being a 1, I'm going to edit this to a 4. So if I take my a times b to the 4th power, I should get 4,000. And I get very close, right? So there is an issue with some internal decimals and some rounding things, but this is a great answer. You would not get quite the same result with these decimal approximations, but rounding to 2 decimal places would be fine.